All right, so for number 1 here, okay, we're looking for the number of moles, which means we're looking for which part of this equation? N, right? Okay, so we're looking for N. We want to write down our givens here first. First, they tell us that we're looking for the number of moles, so that's our question mark. Then they tell us that it is carbon dioxide we are dealing with, okay? So I need to write the formula for carbon dioxide and then calculate its molar mass. So we got 12.01, that's our carbon, plus we have 2 oxygens, that's 16 times 2. All right, so we're looking at 44.01 grams per mole as our molar mass. Everyone with me so far? Okay. They also tell us in the question that we are dealing with 150 grams of the carbon dioxide. So from here, we want to solve for N, which means we don't need to manipulate the formula at all. It's already set up to solve for N. All we have to do is take our 150 grams and divide it by the molar mass, 44.01, okay, and we will have our number of moles. Okay, so 150 divided by 44.01. And I think my smartboard is out of alignment again. Come on. Okay, so we are looking at 3.41 moles. As my final answer. Okay, questions on number 1. Okay, keep going then. I'll do question number 2 here in a few more minutes. Okay, so for number 2 here, okay, we're looking for the mass. So this time we're looking for little m of 26.5 moles. So they told us what N is, of cobalt 2 bromide. All right, so cobalt 2 bromide means use the cobalt with the 2+ charge. Bromine is a -1, so we got CoBr2, okay, as our formula here. All right, so our molar mass, we're going to have 58.93. That's our cobalt, plus 79.9 times 2. That's our 2 bromines. All right, so we are looking at 218.73 moles. Grams per mole, sorry, grams per mole. All right, so there's our molar mass. All right, so now we have this formula, N equals little m over big M, but we need to solve for little m. Since it's already on the top, that's a good place to leave it. I need to move big M. So in order to move big M, what do? Multiply, because I want to do the opposite. Okay, so to move something, I do the opposite. That's rule number 1 of algebra. Rule number 2 of algebra, what you do to one side, you do to the other. And now I've moved big M over, and I'm solving for little m. Okay, so little m is going to equal 218.73, okay, the molar mass, multiplied by the number of moles, 26.5. All right, so we've got 5,796.35. And that's going to be, what are the units going to be for that? Grams, because it's mass. Okay, so that one there, we'd have a mark for the answer, we'd have a mark for plugging in numbers, okay? We'd have a mark for our givens and a mark for manipulating the equation, so that would be a 4 mark question. Okay, how many people have done number 3? Okay, let's have a look at number 3. So on number 3, we're being asked how many molecules, okay, so that's what we're looking for, number of molecules, okay, of sodium sulfide, so that'll help me get big M. Sodium is a +1, sulfur is a -2, so I've got Na2S here, okay, so that'll be 22.99 plus 32.07, no, 30 point, yeah, 30. Okay, and that'll be, sorry, this 22.99 needs to be multiplied by 2 because there's 2 of them. Okay, so 22.99 times 2 plus 32.07. All right, 78.05 grams per mole. All right, so I've got that, and I have the mass as well, 29 grams. All right, if I'm going to find the number of molecules, I first need to find the number of what? Moles. I need to find the number of moles. Okay, that's the part of the mole equation right now that I don't have because I have big M and I have little m. So I'm going to solve for the number of moles, okay, just by plugging my numbers into that formula. So N will equal 29 grams divided by 78.05. So I have less than a mole for sure. All right, so I have 0.3715 moles. Okay, I'm just rounding off. I'm going to keep all the numbers in my calculator. I'm just not going to write them all here. All right, now that I know the number of moles, how can that help me get the number of molecules? What other number do I need here? I need Avogadro's number. What does Avogadro's number tell me? Right, it's the number of molecules in a mole, or particles in general, but in this case it's molecules. Okay, and that is 6.02 times 10 to the 23. Okay, so if that's how many there are in 1 mole, and I have 0.3715 moles, what do I do with these two numbers to get the number of molecules? I multiply them, exactly. In the same way that if I said you had 3 dozen of something, you would calculate how many that is by going 3 times 12, the number in a dozen, right? So that's what we're going to do here. Okay, number of molecules equals N times Av's number. So that'll look like this, 0.3715 times 6.02 times 10 to the 23. All right, so I'm going to take that number, and then I'm going to multiply it by Avogadro's number, which I have to put in brackets, 6.02, second function, exponent 23. Okay, so we got that. There's my number of molecules, 2.24 times 10 to the 23. All right, so we'd be looking at probably again a 4, maybe a 5-mark question. We'd have 1 for the answer, okay, 1 for plugging in our numbers here, okay, 1 for our givens, 1 for calculating the number of moles, okay, yeah, probably something like that. Okay, how many people have done number 4? All right, I'm going to give you a few more minutes on number 4, and then we'll walk through that one together as well. All right, so let's look at number 4 here. So on number 4, they are asking us to calculate the mass. So that means we're looking for little m. They're telling us the number of molecules. Okay, and that is going to be 7.2 times 10 to the 23. Okay, and they tell us the material is diphosphorus pentaoxide. All right, so that's going to be 30.97 on your guys, or 30.98? 30.97? Okay, times 2 plus 16 times 5. All right, so we're looking at 141.94 grams per mole. Okay, if I'm going to get mass, I need molar mass, which I have, and I need the number of moles, which I don't have. Is there a way for me to get it using the number of molecules? Okay, how do I do that? I have the number of molecules, and I have Avogadro's number, which tells me how many molecules are in 1 mole. What do I do with those two numbers? Divide them, exactly. Okay, so to calculate the number of moles, means to take the number of molecules and divide by Av's number. So that means 7.2 times 10 to the 23 divided by 6.02 times 10 to the 23. All right, so we've got 7.2, and I wouldn't even have to put in the 23 here. I could just divide 7.2 by 6.02, but that's fine. We'll show the whole thing. All right, so we are looking at 1.196 moles. Okay, now that I have N, I can calculate little m because I have the molar mass as well. So now I can use the mole equation again. I'll take my, I'm going to manipulate that for m. Okay, so little m is going to mean N times big M. So that'll be our 1.196 that we just calculated, multiplied by our molar mass that we calculated earlier. And that'll tell us the mass. So times 141.94. Okay, so we have 169.76 grams. Okay, how are we feeling about those? Okay, I mean, we got all week to work on these, so there's nothing, to be terribly worried about. So what we're going to do today, okay, I'll give you a little break here in just a second, but what we're going to do is continue to work on the worksheet with the mole equation problems on it from yesterday, okay, get practiced up with that. Tomorrow, I'll do a unit exam review. Okay, so we'll talk about what's going to be on the test, what we've covered in the unit that's important, okay, all of that kind of stuff. Thursday, kind of be, mole equation stuff. After our quiz, we'll see how we're doing with the mole equation because Thursday's quiz will be on the mole, and then we'll know how much time we need to spend Thursday, Friday on that because obviously your unit exam is coming up very soon. Okay, the 18th is what, Monday? Yeah. Okay, so it's coming up real soon. Now, I did put the unit exam review package on Google Classroom yesterday. So it's on there now. You might want to have a look at it. Okay, the key is there as well. Okay, so you can start picking away. You don't need to be spending 3 hours a night studying yet. Okay, yet. At some point you should, okay? But for right now, okay, take, 10 or 15 minutes, do a couple of things, try a couple of reactions and things like that at home, okay? And then, on the weekend, over those 2 days on the weekend, you should spend a few hours getting ready for your unit exam, okay? Because you want to be well prepared. All right, I'll give you a 5-minute break here, and then we'll get back to this stuff. So for question number 3, they're asking you to use the mole equation. So that's N equals little m over big M. This time they're asking you to solve for the mass of each sample. Okay, so you have to manipulate it and then solve for, okay, the mass of 2.3 moles of nickel or 4.2 moles of carbon dioxide, okay, whatever it happens to be. Okay, you need to solve for that. When you get to number 4, okay, and number 5, okay, those should be fairly straightforward as well. Okay, those are like 3 and 4 from the examples we did this morning. Okay, when we get to number 6, I'll talk about 6 and 7, okay, in a little bit. Okay, but for right now, let's work on 3, 4, and 5. So the big thing with 5 and 6, and the big thing with 5 and 6 here is we're looking for, for 5, it's fairly easy. How many molecules of water are in 1,000 grams? Okay, we just have to find N. Okay, so N is little m over big M. Okay, we have 1,000 grams. Okay, divided by 18.02, which is the molar mass of water. Okay, that gets us N, and then we multiply N by Avogadro's number. Okay, the problem with number 6 is the wording. Okay, when we're dealing with how many molecules of something, it's simple. We just plug everything in. The problem with number 6 is that oxygen as O2 is a molecule. And every molecule of oxygen has how many atoms? 2. Okay, so if I'm looking at how many oxygen atoms are in 64 grams of oxygen gas, there's kind of two ways to go about this. Okay, if I find out what the molar mass of oxygen gas is, it's 32 grams per mole because every oxygen molecule has 2 atoms in it. Okay, if I go about figuring out how many moles that is, I divide it by, so I take my 32 grams per mole, okay, and I take 64 grams, I divide it by 32, and I find that there are 2 moles. Okay, when I multiply that by Avogadro's number, I don't get the number in the key, do I? Okay, why not? Exactly. If I do it this way, I calculate the number of oxygen molecules. So I'll get a number that's half of the number on the key because it's the number of molecules. I have to multiply it again by 2 in order to get, okay, the number of atoms. Okay? If I just did this and used 16, then I'll get the right number right off the bat because that's the mass of an oxygen atom. Okay? Then I'll get the right number. Everybody follow? So there's 2 ways to do it, but you just have to realize it's all that question is really asking is, do you understand the difference between a molecule of oxygen and an atom of oxygen? Oxygen doesn't come by itself as single atoms. It always comes as pairs. Okay? So just kind of a weird one. It's not something that comes up very often, but it's just there to make sure we understand there's a difference between a molecular element like oxygen and then, an element like lithium that comes as a single. Okay. How are we doing with the rest of these? Anyone like past number 6 and 7? Okay, so for number 7 here, I just want to talk about that one as well because it's kind of the same idea. Which contains more atoms? A mole of iron or a mole of oxygen gas? A mole of oxygen gas. Again, iron comes as a single. So if I have a mole of iron, I have 6.02 times 10 to the 23 atoms of iron. But if I have 1 mole of oxygen, I have 6.02 times 10 to the 23 molecules of oxygen, each molecule containing 2 atoms. So I would actually have more atoms if I had a mole of oxygen gas than if I had a mole of iron, all right? Because a lot of people, they look at that and they say, no, Coderre, it's the same thing. It's, and then they'll say something like, it's like a pound of bricks and a ton of bricks and a ton of feathers. It's a ton both ways. And like, well, actually it isn't. Okay, in this case, it's not exactly the same because again, oxygen comes as a pair. Okay. All right. So for tomorrow, like I say, we're going to work. We're going to do our unit exam review tomorrow, right? And then we'll do some more mole stuff on Thursday after the quiz, and we'll see how we're doing with that. Okay, whether on Friday we're moving on to Unit 2. Okay, or whether we're going to spend one more day on moles. All right, so that'll kind of be determined by how we do on the reaction assignment and the mole equation stuff. Okay. All right, but you still got a few minutes. I didn't say pack up. Okay, keep working on this till the end. I just wanted to talk about those couple of questions there.